we are looking at lesson 3.6. And to be honest, this is lesson 3.6 part 1. After I copied these notes, I decided we're not going to do lesson 3.6 part 2. So that will end up just being a page we skip in our notes. But we are looking at lesson 3.6 part 1. We spent, the last 3 days going over just solving inequalities, right? 1-step, 2-step, multi-step. Today we're looking at compound inequalities. And if you look down at the bottom of your notes, we're looking when there's 2 inequalities within one problem. Now, here's the deal though. The solving is just the same. And the steps are there. You guys know, just like solving equations, just like solving inequalities, you guys know the steps. Now, so compound inequality definition consists of 2 distinct inequalities joined by the word and or the word or. So compound inequalities will always use the word and or the word or. Now, an and inequality. An and inequality is once you do the shading, it's the overlap. Okay, so when you use the word and, it's where the overlap is. So let's look at these. How do we graph x greater than or equal to 2? You guys know this. We've done this.
X closed. Yeah, closed circle.
We're going to have some kind of dot or circle at 2. Why are you guys telling me it's closed? Because it's equal to. And then because it's greater than, we're going to go to the right.
I'm pretty sure.
So you know that basic, right?
Yeah. And then 5 is closed and it goes to the left.
Okay. X less than or equal to 5. So it's equal to, so it's closed again. This one says less than, so we're going to go to the left. Now,
that one.
huh?
Can I do that one?
Okay, hold on a second. This one says, okay, x, it's saying on the same graph, we want x greater than or equal to 2 and x less than or equal to 4. The word and or the word or makes a big difference of how we think.
Yeah.
Notice the word and
We connect.
says it contains the overlap. So where are we shading for our final answer? Did you know, Riley? Where does it overlap? It overlaps from 2 to 5, yes?
Yeah.
As you compare these number lines, there's overlapping here at 2, 3, 4, 5, yes? Is there overlapping at 1?
No.
Is there overlapping at 6? No. It's overlapping from 2 to 5. So your answer for this one would be circles at both 2 and 5.
What is the
Closed circles because they are equal to, and the shading would be in between.
and on the other?
Hold on. Don't get ahead of me here. So what I want you to realize here is if you are asked to graph something that is x greater than or equal to 2 and x less than or equal to 5, general rule of thumb is you're shading in the middle. You're shading in between the two numbers. Also, we'll talk about this a lot. This could also be written as 2 less than or equal to x less than or equal to 5. And this is just indicating that the x represents what's shaded. So the shading is between 2 and 5. Okay? Now let's talk about or. What's it say up here about or? Or contains both. Each graph. It's not just the overlap. It's anything you shade. Okay, so when we are looking at the word or.
They don't.
So now let's look at one piece. X less than 1. How do we graph x less than 1?
Open circle to this.
Open circle X to the left.
Okay, open circle. because it is not equal to, and you're just going left of 1.
1.
X greater than or equal to 3.
Closer.
Closer would go to the left. Right.
This time, closed circle because it's equal to again. But it says greater than,
And then,
so we're going to the right.
and then you go to the 1 and the 3 and then you shade in the middle.
No.
No, because it's
Okay.
or, so it's gonna have both of them.
With or, you're shading whatever you shade up above here. So they don't have to overlap. You're just shading whatever. So where's x less than 1? X less than 1 is left of 1.
Oh.
X greater than or equal to 3. Where's x greater than or equal to 3? 3 and to the right. So a traditional or statement, the shading goes out. It goes out both ends. Now, the only way you can write an or statement is by putting the word or in between. You cannot combine it into one joint statement like I could over here with the and statement. Okay? So that's a little bit about compound inequalities. Now, I think I have this next part on the next slide, but first of all, FYI, it's not supposed to say inconclusive. It's just supposed to say inclusive. A little bit of a typo there. So pretend the word is inclusive. And I just want you to be aware, because I saw in homework, I believe, when you see the word inclusive, inclusive means the endpoints are included. So if something is inclusive, that means, like this one over here, you're going to fill in the endpoints. They're going to be closed circles, is what we're saying here. So this one, 2, or x is between 2 and 5 inclusive. So when you hear the word inclusive, think closed circles. That's what you want to think of when you hear the word inclusive, is that my circles are filled in. Okay? And that's a vocabulary word you need to be familiar with. Bless you. And I think, as I said, I think I have it at the top of the next page. Yeah, I do. So right here, if you didn't write it down, I had written inclusive means closed circles on the endpoints. Excuse me. Okay. In these examples here, it asks us to write and graph, which means it has it in words. For instance, all real numbers greater than or equal to -4 and less than 6. But it's also asking me to write an inequality there and to graph it. Now,
How I was looking.
huh?
Right, how I was looking.
Yeah, like with x's, less than, greater than signs, that type. So, all real numbers greater than or equal to -4. Worry about that piece. All real numbers greater than or equal to -4. How do I write that? Pick a variable. What letter do you want to use?
X.
X.
R.
Okay, you pick your letter. Now, how do I write this?
X equals 4.
Not equals. X is greater than or equal to -4 for that first piece. Then it gives me the word and. We'll talk about and in a moment. Less than 6. How do we write numbers less than 6?
-6.
No. Think about our inequality signs. Less than 6, what's a less than symbol? X is less than 6. Don't transfer over to subtraction. I know, easy to do, but just X is less than 6. So right there, that's what we're looking at. Now, let's look at what the graph is going to look like.
I'll be the graph.
Robbie, are you with me? Take a stretch break if you need to.
Sorry, I just didn't sleep very much last night.
X
As I
goes
said.
in the middle.
If I'm trying to graph X greater than or equal to -4 and X less than 6, what kind of numbers am I going to have on my number line?
-4 through 6,
-4 and 6 at least, right? Because there's a -4 in the problem, there's a 6 in the problem. Now, there's -4. I'm trying to shortcut here a little bit. I put -4. I put the little, I kind of count up. I just didn't label every number. I put 0. I marked 1, 2, 3, 4, 5, and then I did 6 and I labeled 6. Now, with that in mind, where is X greater than or equal to -4?
Don't you have to put dollars in the middle?
Okay, listen to my question right now. One question at a time. How do we graph X greater than or equal to -4? If it's X greater than or equal to -4, what do I need at -4? Come on, guys, you guys all know this. What kind of circle do I need at -4?
Close circle. Close. I said close circle.
Nope.
And then on 6, you can open circle.
Okay, hold on. Just worrying about -4. -4, I need a closed circle. Where am I going to shade from -4? Okay, and for the moment, I'm just going to kind of put an arrow there. Just for the moment. Now, X less than 6. What do I need at 6?
Oh, the open circle.
Here we need the open circle. Which way am I shading from 6? It's less than, so we're going left. Now, this is what type of statement?
And
It's an and statement. And means we shade, what's it say up above? Where they overlap. Where are these graphs going to overlap?
that's 0.
And not just at 0, but everywhere in between -4 and 6. So my shading is going to be between -4 and 6.
So pretty much that one.
Now, when we write this, can't remember what Math Excel requires, but I bet they won't be happy with you just writing X greater than or equal to -4 and X less than 6. When the shading is between, what shading are the numbers between here? It's between -4 and 6. So what you're going to need to get in the habit of doing, kind of like, you see this right here, 2 less than or equal to X less than or equal to 5.
Yep.
We're going to have to do that same thing. Where we put the smaller number on the left, so I put -4 on the left. Bigger number on the right, so I put 6 on the right. Now it's X less than 6, so what number goes right here? X less than 6. Now, be careful. This originally says X greater than or equal to -4, but my X and -4 flip, and so this is also less than or equal to. Those signs in that situation will always face the same direction. Okay? Okay, let's try the next one. All numbers less than or equal to 2.5 or greater than 6. So go back and look at the phrase, all numbers less than or equal to 2.5 or greater than 6. If you look up above, because it's an or statement, we just get to put the word or in the middle. How do we write a statement for less than or equal to 2.5?
2.5.
What always has to come first?
Negative. No.
What do I always put first? And when I'm writing these, an x, right? So x less than or equal to 2.5. So that is less than or equal to 2.5. And then 2.5. Or it says greater than 6. So this time we start with x,
Plus 6.
not plus 6,
Well, x
greater than 6. So with an or statement, you always just write the two statements together with the word or in between.
Oh, this next is gonna be.
Hold on, we gotta graph that one before you move on.
Oh,
I almost forgot.
So did I.
What kind of numbers have to be on this graph?
2. No.
2.5.
2.5 and 6 minimum, right?
Yeah.
So if I put 6 here, 5, 4, 3, 2, 1, 0. Where's 2.5 going to be?
Middle of 2 and 3.
Middle of 2 and 3, right? I don't care. You set up your graph however you want to, as long as you're okay with the idea of what we're doing here. Now, this is an or. A typical or graph, look up above. Typical or graph, the shading is going out. So, x less than or equal to 2.5. What kind of circle do I need on 2.5? Closed, and we're moving to the left. X greater than 6.
It's going to be open to the right.
Open. And moving to the right. Okay. Now, one more. I'm going to look at the graph on this one first, I think. All real numbers between -2 and 2.
Which is
What does that look like on a graph? Where are numbers between -2 and 2? Where do I have to shape?
Between the 2 and 3.
If it says all real numbers between -2 and 2,
Just a -2 and then 2.
right, between them. So where's between them?
1 and 1.
1, 0, -1. It's going to be all shaded. When they say between, it's everything in between. So don't forget your decimals and fractions. Now, it just says between -2 and 2. Does it include -2 and 2? Does it say anything about including -2 and 2? Nope. So these are going to be open circles. If it said inclusive,
Then it'll be open and closed.
you know, they'd both be closed. You'd fill them in. Okay? As we write this is going to look up like the first one. See, the first one, the shading was between -4 and 6.
Yeah.
This one, my shading was between -2 and 0, -2 and 2. So when my shading is between them, put X in the middle, bigger number at the right, smaller number at the left. It was x is smaller than 2 because it went left of 2. So we used less than. Officially, it is greater than negative 2, but this is flipped around. So that's why I'm putting it like that. Okay, so negative 2, less than x, less than 2.
I'm so tired for the day.
Do we need a quick stand up and stretch break? Walk a lap around your desk.
No.
No, thank you.
Walk a lap around another desk then. I think we do because too many of you are zonking out on me here.
It's been a rough day.
It's a Tuesday, first of all. It's a Tuesday after daylight savings time. I struggled to get out of bed. I'm not going to deny it.
I got out of bed easier.
So. I did not. It was hard this morning.
It's like I hate the time.
The only
Okay.
way I've been staying awake is from eating sushi.
Well, we've got 4 problems to solve down here. We've got to be able to solve these. Now, good news is you already have an idea of how to solve because the solving's not any different from the others. Okay? Are we ready to solve?
Yeah.
Yeah.
And I don't know if I'm going to have us graph these necessarily or not. We might just solve them. Exactly. Okay. Negative 2, less than x plus 2, less than or equal to 5. Now, okay, are we ready?
Yeah. Oh, Josh.
What are we always solving for?
2.
We're always trying to solve for x, right? We want to get x by itself. Now, this one's a little different because there's 3 pieces. Did you catch that? My job when I get down to the end is to have x by itself in the middle. Kind of like the one we just graphed. So, what's hanging out with x that we need to get away from x?
Plus 2.
Plus 2.
Plus 2.
So how do you undo a plus 2? Subtract 2.
Oh, these ones I should know.
Now, if you subtract 2 in the middle,
It's doing 2.
we're going to have to subtract 2 on the left and
Give the 5.
on the right. There's 3 sides, so you're subtracting 2 3 times.
Okay.
The left, the middle, the right.
Well, the first one crosses up.
Nope. Negative 2 minus 2 is not 0. If you're at negative 2 and you go 2 farther to the left, you're at negative 4.
Cool tree.
I'm going to carry down my less than sign. I'm going to carry down my x. 2 minus 2 will,
Yes, that's
that's what will cancel.
That's what I'm thinking.
Carry down my
Okay.
less than or equal to.
And then 5 minus 2, 5 is 3.
5 minus 2 is 3. Is my x by itself?
No.
Is it by itself in the middle?
Yeah.
It is.
So that's the answer.
That's your answer. Because I want you to be able to identify it for Math Excel, where would the shading be here?
To the left.
If x is in the middle of these two numbers, where's the shading?
In the middle.
In the middle of these two numbers. Am I making sense?
Yeah.
If x is in the middle of these two numbers, my shading is in the middle of these two numbers. And I'm just taking a shortcut here, but I just want to show you that if there's negative 4 and 3, my shading is in between negative 4 and 3 because x is in the middle. Open circle on negative 4, close circle on 3. Now,
That's next one.
let me guess, you don't like it because you see a fraction?
No, the one over there. Yeah.
Yeah.
The fraction. Yep.
Okay. So, last one I want to get x by itself in the middle. This one I want to get
And like.
m by itself in the middle. So, think about what all is being done to m. 3m plus 6 divided by 2. What was the last thing I just said? Divided by 2. 3m plus 6 divided by 2.
So you divide it.
How do you undo divide by 2?
Multiply it.
We multiply by 2. That means I'm going to multiply by 2 in the middle. If I multiply by 2 in the middle,
All the way around.
got to multiply by 2 on the right, got to multiply by 2 on the left. Okay, this could be challenging math.
But you have
What's 2 times 0?
0.
0. Okay, didn't catch David.
3 times.
Carry down your less than or equal to.
Alright, 3 times 2.
Hold on. Don't jump. What happens with these 2's in the middle?
They cancel out.
They cancel, leaving me with
3 plus 6.
3m plus 6. Carry down your sign. And now, what is 3 times 2? 6.
But you're not divide by 2.
Hold on. How do I get m by itself? So now what's still hanging out with m?
This 0.
Subtract 6 all the way around.
It's 3m plus 6. So 3 times m plus 6. What's the last thing done that we need to undo?
This is
The plus 6? How do we undo a plus 6?
we subtract 6.
Subtract 6. If you subtract 6 in the middle, subtract 6 on the left, subtract 6 on the right.
Oh, well, so negative 6 times 0 is negative 6.
Hold on. 0 minus 6, you mean. Again, don't jump ahead of me here. 0 minus 6 is,
0.
no,
Negative 6.
negative 6. Less than or equal to. 3m is still 3m. 6 minus 6,
12.
Oh,
6 minus 6 is
0.
0.
As you said. Okay, well, you're not done. Alright.
Why am I not done yet?
Just have to get
Oh,
it. So,
because there's still 3 with n.
Okay,
And now you just divide 3 by this.
what's keeping the 3 and m together?
And the multiplication.
Multiplication, so we're going to divide. Negative 6 divided by 3.
Negative 2.
Negative 2. Carry down the sign. Less than or equal to. 3m divided by 3.
M.
M. Carry down your sign. Less than or equal to. 0 divided by 3.
0.
0. Hey guys, we got 2 more here.
what
Gotta help me out here. Now, what's different about these next 2?
they're
They're both 4.
They're or statements. Or statements are no different than what you've been doing all along. You solve one, you get that answer, and then you solve the other, and you get that answer. So, should I call them all my sleeping beauties?
yeah, because I've been talking this whole time.
I just asked a question. Yes, I should. Okay, Jacob. If it's m plus 7 greater than 10, how do I get m by itself if it's m plus 7? The opposite of adding 7? Don't think too hard. What's the opposite of adding? Subtracting. So if it's m plus 7, we're going to subtract 7. You were hoping to get out of it by getting up to blow your nose.
No, I wasn't. I was just like needing to blow my nose.
Okay. Well, I made you answer a question first. You survived. Okay. 7 minus 7
0.
cancels. M. Carry my sign down. Greater than. What's 10 minus 7?
No, 10, 9. Yeah. Hold on. 2, 5, 6, 3.
3. Now, you must carry the word in the middle down. So I need to carry the word or down. Now, 3m less than -6. This time, I want to get m by itself. It's 3 times m. How do I, if it's 3 times m, what was I going to do, Rylan? Divide by 3. 3m divided by 3 cancels. M. Carry the less than sign down. -6 divided by 3. -2.
No, you're still on it.
Why am I not done?
Because you have to add.
Do I have my m's by themselves?
Yeah, you do.
Yeah. And it's an or statement, so you can't put it together. It's m greater than 3 or m less than 2. And again, just realize, I'm not getting fancy here, but m greater than 3, notice on an or statement that graph goes out. M less than -2. On an or statement, that graph goes out.
Out.
Okay? So or statements go out, and statements are in the middle. Okay, guys.
Last problem of the day.
Let's do it by yourself.
No, because we don't have enough time for me to straighten out the mistakes if we get caught. So otherwise I would, trust me. -2, -7. -2y plus 7 less than 1. If it's -y plus 2, 7.
You subtract.
Oh my god. -2y plus 7.
You subtract.
Get slow.
Okay, what am I going to subtract?
The 7.
Okay, if it's -2y plus 7, we're going to subtract 7.
Hey, Rob, looks way back there, really good.
David,
Yes.
you.
I'm sorry.
-2y carries down. 7 minus 7
0.
cancels. Carry down my less than sign. What's 1 minus 7?
6. -6.
-6, and I'll go with you. Okay,
But you're still not.
I'm not done because y's not by its.
Self. So you have
Self.
to subtract the.
Back it up.
Oh.
If it's -2 times y, what's going to undo -2 times y?
Divide.
Divide. If we divide by -2 on the left, we divide on the right.
Well, you can cross out this 2's.
-2's cancel.
And it's going to be y equals. No, greater than
What is -6 divided by -2?
-12. Positive 12.
6 divided by 2?
Oh. Hold on. Calculator.
How about a -6 divided by -2 is a
3.
positive 3.
Oh, the both negative brother.
Now, what's the catch on this one?
Oh, you have to flip it.
Why am I flipping?
Because it's negative. You got me on that trick so bad.
Okay. Because I divided by -2, that inequality sign has to flip. Now, I'm going to carry down my word, or I'm going to solve the other one. If it's 4y plus 3,
Subtract.
subtract the 3. 4y,
Y.
3's cancel. Less than or equal to -5 minus 3, -8. Next time when I tell you guys to get calculators, get them. If it's 4 times y,
It's 4y.
divide by 4.
Cross out, so 4. No y equals.
So 4's cancel. You got y. Negative 8 divided by 4. Well, 8 divided by 4 is 2. What's a negative divided by a positive?
Negative.
A negative. Do I keep the sign or flip the sign?
Flip it. It's because no, you keep it because it's a positive.
I'm dividing by positive 4 here, so I keep my sign. So y greater than 3 or y less than or equal to negative 2.
For your afternoon announcement. Tonight, Team Blast will be hosting a roller skating event. Doors will open at 4 o'clock. You'll leave Team Blast at 4:30 and return at 8:30. $10 covers skating, pizza, and a drink. Tutoring this week will be available on Wednesday, tomorrow after school. Attention students in grades 9 through 12. Tomorrow, March 16th, and Thursday, March 17th, there will be auditions for Drama Club, Spring Play, 12 Angry
A lot
Birds.
of these kids could be good
Auditions
at that.
are open to students in grades 9 through 12. If you are a student who was previously a cast member of 12 Angry Men, be sure to
I
audition.
always love an angry.
Auditions will be in Miss Minnick's room from 3:15 until 4.
Please listen.
Auditions will include reading from the script of 12 Angry Birds. If you are unable to attend your audition, see Miss Minnick by June Thursday. World War II Club and 6th graders, your pie money is due by Friday, March 18th. Your books are now available to order. See Miss Higgins in room 208 if you're interested. Saga field trip to Kokomo facility will now be Wednesday, March 23rd from 3:15 to 4:15. See Mrs. Holman by this Friday, March 18th for your permission slip. The Theta Delta chapter of Tipton is sponsoring a renewable $1,000 scholarship. More info can be found in the guidance office or in your email. The deadline to submit your application is April the 15th. Beck Hybrids is looking for summer help. Responsibilities include pollinating corn plants, tending weeds, and walking fields. Pay starts at $12 an hour and is available to anyone ages 14 and up. To apply, go to beckhybrids.com. Seniors, all candy money was due yesterday. If you have not turned that in, please turn that in to Mrs. Fernand immediately. Middle schoolers, if you are interested in track and didn't make it to the meeting, please stop by the high school office and see Mrs. Rummel to sign up and receive an informational sheet. Be sure to have a physical on file. Practice starts tomorrow after school. There will be no games tonight, and if Garrett Muller could report to the high school gym, that would be amazing. Have a great night, everyone.
Okay, your homework tonight is lesson 3.6. Unfortunately, it looks like all of you have 2 homeworks to do. So you need to get caught up on 3.4 and you need to do 3.6.